The standard error is a single metric that can be used to sum up the variation in a sampling distribution of some statistic. Recall the 1,000 simulation results of the Toyota car prices, where each time we got a bootstrap sample and took the mean, and we ended up with this histogram, which was one way to look at the variability in the resample results. Another way is not to do the graph, but simply to take the standard deviation of the resample means, which is more commonly called the standard error of the sample mean. Now, it's important to distinguish here between the standard deviation of the sample data itself versus the standard deviation of the resample means. Obviously, the latter is going to be much narrower because each one is an average value as opposed to being an individual value in the sample. So we can also estimate the standard error directly from the sample data without doing that in Bootstrap, provided that the sampling distribution is fairly normal. You just divide the sample standard deviation, that's of the sample data, by the square root of the sample size. And once again, remember that we're distinguishing here between the standard deviation of the sample data versus the standard error, abbreviated SE, which is the sample mean standard deviation, how much the mean differs from one resample to another, not how much the individual data points differ from one to another. Now, this is the formula approach here on this slide, but the beauty of the Bootstrap approach is that it applies to any sample estimator or even estimate from a model. So here you have this is for the mean, but in a formula world you're going to have to find a different equivalence for each standard error that you want to estimate. In the Bootstrap world, it's just the same process. You take a bunch of Bootstrap resamples and find the standard deviation of whatever it is your statistic is that you're tracking.